Hi there everyone, right, standard form. You might have done standard form before, you might not have done. So let's start right at the beginning. Firstly, what is standard form? Well, standard form is just another way of writing numbers, and you get this a lot in science particularly. And in science, and in those kind of fields, we have like really big numbers and we have really small numbers. And it's just a good way of writing those. So it's useful for really small numbers or very large numbers. So, for example, you might be talking about the size of an atom, and that's really really tiny. So it'll be 0. I don't know 0.00000001 millimeters across or something, really tiny number. Or you might be talking about how many atoms in the human body, or in space. Enormous vast numbers. And so standard form is just a really neat way of writing these. And it looks like this. It has two parts. And the first part is a single digit, possibly followed by a decimal point with some other stuff, right? But there is never, you never have sort of 0 point, something or other. And you never have two digits in front of the decimal points. You never have that either. So just a single digit, possibly followed by a decimal point. And then you have times 10 to a power. And that power, basically, I'll tell you what, we'll explain it like this, right? So let's start off with 2.45 equals 2.45. I mean, that presumably we're okay with that, all right? Now, if I times both sides by 10, well, I will get this. So 2.45 times by 10 is 24.5. All right, it's kind of adjusted my number one place bigger. Remember, every time I times by 10, my number gets one place bigger. Now, if I do it again, so 2.45 times 10 would be 245. But this bit here, this times 10 times 10, obviously we could neaten up to just be 10 squared. All right, now look, this is closer to what we're talking about here. So when we say times 10 squared, it means actually it's this number, but two places bigger. It's like timesing by 10 twice. So 2.45 times 10 to the power of 2, which is standard form, is the same as 245. And I can keep timesing this by 10. All right, so I'll times this by 10. So my power then gets one bigger, and so does the number it represents. Yeah, 2.45 times 10 to the power of 3 is really this, but 3 places bigger, 2,450. Right, and then times it by 10 again, times it by 10 again. And this shows me then that actually 2.45 times 10 to the power of 5 is actually equal to 245,000, like that. All right, so it just represents numbers. So this is a normal number, a perfectly normal number. It's just written in standard form. Remember, one digit in front of a decimal point if there is one, and then times 10 to a power. And that power is how many places bigger my number is. Okay, so we've got 7,200,000 here. Now, if I want to write that in standard form, I'm first of all going to take these two digits at the front here because they've got to be in my number, and there's not going to be any sort of gap between them. I'm not going to suddenly put numbers between them or zeros between them. So those are my decimal parts. Now, the decimal point must be after that first proper digit. So it's 7.2. Then work out what power of 10 you need. Now, my decimal point has ended up here between the 7 and the 2. Now, really on this number, although it's not written, we know it's really over here, isn't it? It's on the right-hand side. So it's gone 1, 2, 3, 4, 5. My number is really 6 places bigger than 7.2. So I put to the power of 6, right? So write the decimal part, make sure the decimal point's in the right place, and then figure out how many places bigger my number needs to be. So let's do it again. Right, same decimal bits then. So 5092, I'm going to write 092. Now the decimal point needs to be after the first digit because there can only be a single digit before the decimal point. And then how many places bigger is my number? Well, it's 1, 2, 3, 4 places bigger to get the decimal point in the right place. So 5.092 times 10 to the power of 4. It's really 4 places bigger than this number. The other one. Okay, same thing again. Write out the decimal part. So 6609. I don't want any zeros after that. Not bothered with those. and the decimal point goes after the first digit. Then how many places bigger is it? 1, 2, 3, 4, 5, 6, 7, 8. It's really moved 8 places, or it needs to be 8 places bigger. Yeah. What about writing things as normal numbers? You can have a turn in a second. So 462, but times 10 to the power 3. So it's really 3 places bigger than this, right? So 4.62. Now, if it jumps 1 place, it will jump that 6, so that's 1 place bigger. And then jump the 2, that's 2 places bigger. And then a 0, 3 places bigger. Okay? Some people like to go, imagine the decimal point moving. 1, 2, and then a third place which would need to have a 0 in it. Right? Or 1.07. Well, write down those. It's got to jump 2 places to jump those decimals. So that's 2 jumps, but I need 5 in total. So there's 3, 4, 5 jumps in all. 107,000 is what that's worth. So 2 places to get it past the 7, and then it's a total of 5. So if that's 2, we need another 3. Yeah. And then lastly, 3.101. So it's got to go 1, 2, 3 jumps to get, or move my number 3 places bigger. So we get 3101. So that's 3 places bigger. There's a total of 6. So there's another 3 to go. Okay, and put in a couple of commas to make the reading the number easier. 3,101,000 is what this really represents. All right. Okay, your turn. There's some numbers. I want you to put the top ones in standard form and the bottom ones as normal numbers, please. So pause and then unpause when you're done. Okay, you've unpaused. Right, so this would be 3.5 times 10 to the power of 1, 2, 3, 4 jumps there. 10 to the power of 4. Okay, 2.08 times by 10 to the power of 1, 2, 3, 4, 5, 6 places bigger. So 10 to the power of 6. Oh, big number here. 7.809 times by 10 to the power of, well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places bigger. So the power of 11. And then going the other way. So we've got 2 jumps to turn it into 516. And then there are 2 more to go. So 51,600. Okay, again, 2 jumps again to get that part as a whole number. So 701. That was 2 jumps. There's 4 more to go. 1, 2, 3, 4 places bigger. So that is 7,010,000. And then 5. Oh, hang on. How many places? 1, 2, 3 to get that number. But there's a total of 5, so there's 2 more to go. 520,300. Okay. Right. I hope you're getting good at those. What about these ones, though? So this time, we've got a small number that we want to write as standard form. Now, the first part of this is the same. Take the decimal part, or the digits that are there, and put the decimal point after the first one. Now, it's going to be 10 to a power, but what power? Well, my number is really 1, 2, 3, 4 places smaller. So that's 4 places it's moved. But because it's really got smaller, it's like dividing by 10 in a way. And we represent this by doing the negative power. Because remember, a negative is a reciprocal. So really, we're timesing this by, if you think of 10 to the power of minus 4 being 1 over 10 to the power of 4, I'm really timesing it by a very tiny number, which is why it's really 4 places smaller. All right. So when we're trying to represent small numbers, we put a negative power. Right. 3.01. That's the easy part, isn't it? But it's now gone 2 places smaller than that, really, over the 3 and then over another 0. So 10 to the power of -2. So write the decimal part with the decimal point in the right place, and then look at the power of 10. How many places has it shifted? So this one is going to be 4.5, because those are the digits, times 10 to the power of, well, it's 1, 2, it's 3 places smaller, so minus 3. And we can do it, going the other way as well. Now this isn't quite as neat as the writing, big numbers as normal numbers, but we'll start with this. Now, I mentioned it's actually 3 places smaller, so it's got to go over the 4, so that's 1 place, and then, so that would be 2. It's got to do 2 more jumps, 1, 2. Okay, and each of those will need a 0 in it. So really, it's 0.00462. It's moved 3 places smaller, and just have a little check of that. Go backwards with it. 1, 2, 3. Yes, the decimal point would be in the right place. So it's not quite as neat and easy, these ones. Right, minus 5. It's really 5 places smaller, so that would be 1 place to jump that digit. So that's 1 jump, and then we need a total of 5. So 1 jump, 2 jumps, 3 jumps, 4 jumps, 5 jumps. So the point must be in front of that 0. So 0.00000107. What about this one? 6 places smaller. So we'll put 3101 over there. Now it's done. It does 1 jump to get over the 3, and then 5 more. So that's 1 jump, 2, 3, 4, 5 places. So it's made. Hang on. No, I haven't done enough, have I? Ah, Mr. Nice. Let's do that again. Let's do that again. Let's get back to a pen. Right. Okay. So it's always worth to double check this. 1 jump to get over the 3, and then 2, 3, 4, 5, 6, because it was 6 places smaller. And always do a little check. 1, 2, 3, 4, 5. Yeah, 6 places would put that decimal point back in that same place. Good. Your turn. Okay. Top numbers, write in standard form, please. The bottom numbers, write as normal numbers again. Pause the video. Off you go. Okay, you've unpaused, or rather, I've unpaused. You haven't unpaused. Oh no, you have unpaused, haven't you? But I didn't pause. Anyway, 7.2, and it has moved 1, 2, 3, 4 places smaller. So 10 to the power of minus 4. Right, 6.34 is the decimal part. How many places have we shifted? 1, 2. It's really 2 places smaller. And then 2.06. Remember, there's always this single digit in front of any decimal point. Never 2 digits. 1, 2, 3, 4 places smaller. So 10 to the power of minus 4. Right, 5.11. Let's give ourselves a bit of space. Now, it's going to jump 1 place, isn't it, to get over the 5. And then I've got 4 more to go. So that's 1 jump, 2, 3, 4. Total of 5 places smaller. 0.0000511. Okay, 3 places smaller. So 1 place jumps that 3. So that's 1 jump, and then 2, 3 jumps in total. 0.00309. Right, 5204. Right, 1 jump gets you past the 5, but it's 7 in total. So that's 1, 2, 3, 4, 5, 6, 7 places smaller. Have a little check. 1, 2, 3, 4, 5, 6, 7. Oui, bon. Très bon. En avant. Right, converting to and from standard form. So at this point, you should pause the video and go off to Dr. Frost, do those questions. They shouldn't take you very long, and then come back to me. Come back to me. We'll do some more standard form. Off you go. You have come back to me. I always knew you would. Is it in standard form? That's the question. 36.5 times 10 to the power 4. Is it in standard form? No, it is not in standard form. It needs to be 3 point 0.65. So same digits and everything, just the decimal point needs to be after that. You can only have a single digit in front of that decimal point, and it can't be 0. But I can't have this as the power of 4 anymore, because otherwise I'd have different numbers. Right, this part, the decimal part at the front, has got one place smaller, which means to compensate, my power gets one number bigger. They do opposites. So if the first bit gets smaller by one place, the power of 10 gets bigger by 1. If the first number got bigger, then my power would get smaller. It's always opposites. Okay, so if I've got, say, this one, look, there's a 0 in front of the decimal point. That's not on. We want 4.67. Now, that number has got one place bigger, which means my power gets one digit smaller. Yeah, so 10 to the power of 6. All right, opposites every time. Just be careful when you get things like negatives, right? Because now my number here is wrong, isn't it? It needs to be 8.93 times by 10. Now, my number here has got 2 places smaller, which means my power is going to get 2 places bigger. But think of your number line. Got -3, 2 places, or 2 numbers bigger, sorry, would be up to -1, wouldn't it? So that means the power is -1. Remember, opposites. This bit has got 2 places smaller. My number gets 2 bigger. Right, this one, it needs to be 3.2 to be in standard form. So my power, now this part has got 2 places bigger, hasn't it? Decimal point, or the numbers have shifted 2 places bigger, which means my number gets 2 smaller. Now this time, it's going to be -7, because on a number line, you've got 0, you've got -5, 2 numbers smaller, sorry, we'll be taking away 2, goes down to -7. So be careful with these negatives. Right, your turn. There's 4 to do. Adjust them so they're now in standard form, please. Oh, you know, pause the video. Usual thing. Right, I've unpaused. Okay, my number needs to be 1 place bigger. 1 place bigger along the world I go. So 7.845 times 10 to the power of. Right, my number has got 1 place smaller, so my number gets 1 bigger, up to 9. This will be 5.1, which means my number has got 2 places bigger, hasn't it? 0.051 is now 5.1, 2 places bigger. So my number gets 2 smaller, so it goes down to 5. 6.702. Right, my number has got smaller by 3 places, which means my power gets 3 bigger. So this one's got 3 smaller, so this one gets 3 bigger. What's 3 bigger than -3? Start at -3. 3 bigger means adding 3, which means I get up to 0. So actually this will be 10 to the power of 0, which is a bit of a stupid standard form number, but you know, the practice is there, isn't it? So 7.05, my number has got 3 places bigger to become 7.05, so my power gets 3 smaller. It does the opposite, 10 to the power of 10. Da-da-da. There we go. Okay. Right, that's how you adjust standard form. Now that's really important for what we're about to do. Always check that they're in standard form, because now we're going to do some multiplying and dividing. Let's have a look. So, example. 3 times 10 to the power of 4 times 10 times 2 times 10 to the power of 3. These are really just 2 numbers times together. In fact, if I was writing them out, it would be 3, 0, 0, 0, 0. So 30,000 times by 2,000. You know, it's just 2 numbers times together, right? So hopefully my number will be equivalent to 6 with 4, 5, 6, 7 zeros. 1, 2, 3, 4, 5, 6, 7 zeros, right? 60 million. But we're going to do it in standard form. And here's how we do it. If you sorry, bit of a voice weird thing going on there. Ignore the brackets for a moment. Actually, everything here is multiplied together. That means when things are multiplied together, it doesn't matter what order you do it in. You know, 3 times 2 is the same as 2 times 3. So we're going to reorder the elements, right? And we're going to reorder them. So we'll put the two sort of decimal parts, you know, this bit here and this one here, the 3 and the 2, next to each other, all right? And we're going to times those together first to get 6. Then we're going to do the times 10 to the power of 4 times 10 to the power of 3, right? Everything's still multiplied together, but this time, what happens with our powers when we multiply, you know, like base numbers together with powers? The powers get added, as we worked on recently, yeah? So 6 times 10 to the power of 7. So that's what you do. You multiply together the two decimal parts, then you multiply together the two powers of 10. And in doing so, remember, you add your powers. Don't multiply the powers, add them because of the index laws. Now, last thing is always check it's still in standard form, because it might not be. In this case, yes, it is. There's a single digit times by 10 to the power of something. Another one. So let's reorder the elements. Let's times together the 5 and the 4.3. Yeah. Now, when I do 5 times 5.3, I get 21.5. That's fine. And let's also then multiply together the two powers of 10. So times 10 to the 9 times 10 to the power of 5. When I do that, I add my powers. So it's 10 to the power of 9 plus 5 is 14. Okay, now it looks like standard form, but it isn't, is it? So always, again, check that it's in standard form. This number here should be 2.15. Which, they've missed out the 1. Let's put the 1 back in. 2.15 times by 10 to the power of 15. God, I need to have a word with whoever sets up these PowerPoints. Right, so that number got one place smaller, so this digit got one bigger. 2.15 times 10 to the power of 15. Yep. More examples then. Let's just do a couple more, right? Just to check, you know, without all the arrows all over the place. Let's first of all times together 2.1 and 4. Now, 2.1, you can use a calculator for these little bits today. And that is 8.4. And then let's times together those two powers of 10. So the 10 to the power of 5 and 10 to the power of 3. Don't need a calculator for that because I'm just adding the powers together to get 10 to the power of 8. Check it's in standard form. Yes, it is. All happy days? Your turn. Have a go at that. Pause the video. Do that one, please. Unpause when you're done. Okay, right. This time, let's make it the sort of all the arrows and stuff a bit easier. Right, 5 times 7 is 35. And the 10 to the 6 and 10 to the 8, add those powers together to get 10 to the power of 14. This is not in standard form though, so we're going to adjust it to become 3.5. Only a single digit in front of any decimal point. Times by 10 to the power of, well, my number got one place smaller, so my power gets one bigger. Good. Excellent. Right, your turn again. 2 more to do. Pause this time, have a go at those. You might need a calculator for these decimal bits. If you didn't, of course, you could just do, you know, do your written methods. Up to you. But pause and unpause when you're done. Okay. Right, first things first. Oh, I haven't taken my pause down. There we go. 7.2 times 5.8. Multiply together the two decimal parts to get 41.76. Times by 10 to the power of, well, 10 to the 4 times 10 to the 7 is 10 to the power of 11, because 7 plus 4 is 11. Right, it's not in standard form though, so we're going to rewrite it. 4.176. My number got one place smaller, so my power gets one bigger, because they need to be equal. It's just compensating. If this moves one place, that needs to mean it needs to move another place as well. This one, 3.7 times 4.2 is 15.54. And then the powers of 10, 10 to the power of 5, 10 to the power of 6 is also 10 to the power of 11. Once again, my number needs to shift to become 1.554. Same digits, just one place smaller. Now, because that got one place smaller, my number here, the power of 10, gets one bigger, so it becomes 10 to the power of 12. Right? Hope you're happy with those. So, quite straightforward, really. Multiply together the decimal bits, and then, add those powers of 10, and then check it's in standard form. Always check. Now, it says more examples, but really it's not more examples, because look what we're doing now. We are doing dividing. Now, it's a very similar thing to what we did before, except with divide. All right, because what we've got here, really, if I wrote this another way, I'd have 14 times 10 to the power of 7 divided by 2 times 10 to the power of 3. Okay, so instead of multiplying, we now divide. So I do 14 divided by 2. You do the same thing. Look at the decimal parts first to get 7. And then what happens when we divide our powers? We subtract. So we do 7, take away 3 is 4. So it's 7 times 10 to the power of 4. Right, so very similar to the multiplying, except you're dividing. And then when you do your powers, you need to subtract. You don't have to write it in this fraction, but I think it kind of visualizes what's going on. You can see it a bit easier. Again, okay, so this time we've got 2.5 times 10 to the power of 10 divided by 12.8 times 10 to the power of negative 4. Okay, be careful with these negatives. First things first, 2.5 divided by, oops, I'm doing this on my calculator, divided by 12.8 is a big long decimal, 0.1953125. Okay, times by 10 to the power of, now I'm doing 10, take away negative 4. Now think what's going to happen here. If you've got, let's just write it up here, 10, which is the first power, take away negative 4, you're taking away a negative, that turns into a plus, doesn't it? 10 plus 4. So the power is 14. But my number is not in standard form. It needs to be 1.953125 times by 10 to the power of, well, my number's got one place bigger, so my power does the opposite, goes one place smaller. That is, the compensating bit. Changing it to make sure it's in standard form is always the same. Doesn't matter if you're multiplying, dividing. If this gets one bigger, this gets one smaller. They do opposites. Your turn. You just about read there. Do that one for us. Pause and then unpause when you've done that one. Make sure you do. Don't just do it in your head. Write it down. Unpause then. Right, so I've got 6 times by 10 to the power of 12 divided by 12 times by 10 to the power of 5. Now I'm going to do this without a calculator this time because I don't need one. 6 divided by 12 is the same as a half. And you can't, loads of people try and do this the other way. They'll do the big number divided by the small number. It doesn't work like that. It's the top number divided by the bottom one. So 0.5 times by 10 to the power of, remember, subtract your powers, 12 take away 5 is 7. Now my number is not in standard form, so I'm going to rewrite it. It should really be 5, not 0.5, times 10 to the power of, well, my number got one bigger, so this power gets one smaller, so power of 6. You might have written 5.0, but of course you don't need that 0.0, you just need the 5. Right? Your turn again. 3 numbers for you to do, so pause, do them, and then unpause when you're done. Okay, again, don't need a calculator for this first one. 12 divided by 3 is 4. And then the powers, subtract your powers, 8 take away 5 is 3. Good. Right, this one, 1.12 divided by 4. Now I'm turning to my calculator for that one just for a bit of speed. Now that is 0.28 times 10 to the power of, well, 11 take away 6 is 5. So 10 to the power of 5. But this is not in standard form. It needs to be 2.8 times by 10 to the power of, my number got 1 bigger, so my power gets 1 smaller, always opposites, 2.8 times 10 to the power of 4. Right, 4.56 divided by 8 is 0.57 times by 10 to the power of 14 take away, that's right, it's up here, 14 take away negative 3, but that's too confusing, two signs together like that, it turns into a plus. If the signs are the same, it's positive. Or, you add. So 17. Right, now, I don't want that as 0.57 because it's not in standard form, so I change it to 5.7 times 10 to the power of, well, this number got 1 bigger, so that number gets 1 smaller, down to 16. So that is multiplying and dividing. Right, we've covered a lot of ground today, and I want you now to go off and do the multiplying and dividing standard form work. Have a go through. I think I've set it so you can actually redo questions if you need to. Obviously, let me know if you're struggling, and we'll try and sort out some kind of help for you, okay? Right, off you go. Well done.